So this is the video for the progress check review for pre-calculus quarter 1. The entire test is no calculator, so your entire review should be no calculator. Refer to the function below to see the fee for the handyman. How much would they charge for a 5-hour job? So I look for where equal to 5 is I'm going to substitute 5 into that equation. That's 10 plus 30 equals $40. Is the function continuous at 5? Well, so we know the bottom piece has this coordinate. The top piece would have a hole because it's not equal to at 5 plus 40. These are different values, so there's going to be a jump. It's not continuous. Is the function continuous on the domain? So does every value exist from 0 to infinity? Since we include 5 here but not here, we still are equal at 5, so yes, because every x value, x greater than equal, is on the graph or in the function or used, however you want to say it. All right, so find g of f. So that becomes x squared minus 10. So instead of x, we put the square root of x plus 10. Then we're going to simplify. Now this is f of g. So in this x, I replace with x squared minus 10. Simplify. Yes, because f of g of x equals x and g of f of x equals x. We're going to do the same thing for 3. So f of g. So in the f function, anywhere there's the x, I'm going to replace with this equation. Now I can distribute the 6 and simplify. So now g of f distribute. That's also x. So they are both inverses. So even, odd, or neither refers to symmetry. Even symmetry is y-axis. Odd is rotational around the origin. And neither is neither. So 1, 2, 3, 4. There are 5 problems here. I'm going to substitute in algebraically a negative x to see if we get the same original equation or not. Well, the square root of negative x does not exist, so I can't even simplify that, so this graph is a neither. So this is negative x to the 1/4 cubed. I like to split apart that rational exponent. So the 1/4 is like the 4th root of, and you can't take an even root of a negative. That doesn't exist again, so this one's a neither. All right, let's try this one. It's gonna be 2, the 5th root of negative x cubed. Okay, so the 5th root of a negative is still negative. So you think to yourself, what times this 5 times is negative? It's still negative because of the odd. And then to an odd power again is still negative. So it's like multiplying by the negative coefficient. So I can simplify it since this equation is completely opposite of that one, it's odd. If you don't like with the x's, we can substitute in 1 and -1 to see what kind of numbers we get. So if I substitute in 1 to the 3/5 is 1, 2 times 1 is 2. Now when we substitute in -1, -1 to the 1/5 is -1, cubed is still -1, that's -2. So these numbers are opposite values, or opposite signs, so the function is odd. I'm going to rewrite this as 1 over x to the 4th. I don't like a negative exponent. So now when I substitute in -x, and -x to an even power is negative times negative times negative times negative. So that is a positive result. Oops, it's a 4. So these equations are exactly the same, so that's an even function. Do the same thing here. Negative to an odd power, so the 1/3 is still negative. So this is odd because of the opposite sign. Accurately graph and find all the other stuff. Okay. I don't like this as a quantity squared. I'm going to write that binomial as times itself. Because what happens is with this factor eliminating, that creates a whole. So when does x plus 3 equal 0? That's at -3. And just this is our remaining equation for getting most of the other answers here. So when I substitute -3 into the remaining function, we get 0 in the numerator divided by -2, so that's a y value of 0. So if you substitute in your x coordinate of the whole, we get 0. Vertical asymptotes are what makes the denominator 0. A horizontal asymptote is I'm going to compare the degrees of the numerator and denominator. You can do that from the very original, you can do that from the reduced, and I see that, let's go back to the original. The degrees are the same, so I'm going to divide the leading coefficients to get my horizontal asymptote. That means there are no slants. Zeros are x-intercepts, and that is when you're, let me write that, x-intercepts, is when your whole equation equals 0. Got some space down here. So solving this, when does x plus 3 equal 0? That's -3. That's our whole. So the whole is on the x. See over here. So right here is the whole. So it's not really an x-intercept because the point is missing. All right, now let's graph it. We've got x equals -1 is for my vertical asymptote. Y equals 1 for the horizontal. I know this piece must go through the hole and approach the asymptotes. On the right-hand side, if I substitute in 0, we get a coordinate of 3, so that is the y-intercept here. So I know my other piece is up in that top right quadrant. All right, for our x approaches. As x approaches -infinity, the y value approaches 1. As x approaches infinity, the y value approaches 1. As we approach -3, this little plus means from the right, so that's this direction. The y value is 0. And as we approach -1 from the left, that's going down to -infinity. Okay, there are no holes for number 6 because none of the factors eliminate. We have a vertical asymptote at x equals 2, because that is when the denominator equals 0. Horizontal asymptote, well, the numerator degree is larger than the denominator, so there is no horizontal, it's a slant. So let's do some division. X minus 2 divided by x squared minus x plus 0. I like to hold the spot for any missing value. Now we're going to do x squared divided by x, multiply, multiply, subtract. X divided by x is positive 1, and that is my slant asymptote. Zeros is when the numerator equals 0, so we have 2 of them at 0 and positive 1. That's like 0, 0, and 1, 0. My slant asymptote is like this, at a y-intercept of 1 with a slope of 1. My vertical asymptote is at 2. So with a slant, and I have to cross through these 2 points, my rational function is going to approach both asymptotes, and this piece is going to be up here. You can pick another value for x to substitute in to figure out where the other pieces lie. Like if we substitute in 3, we're going to get 3 times 2 over 1, that's 6. Ooh, I'm almost right there. So we know that point's on the graph here. So I knew that this part of the function is up between these asymptotes. Okay, as x goes to negative infinity, the graph is going down to negative infinity. As x goes to infinity, the graph is going up to positive infinity. And 2. Okay, as we approach 2 from the right is this way. The graph is going up to infinity. 2 from the left, so that's this piece that's going down to negative infinity. All right, one more. No holes because none of the factors divide. Vertical asymptotes are what makes the denominator 0. Because the degree of the numerator is smaller than the degree of the denominator, the horizontal asymptote is y equals 0, so there is no slant. The zeros, or the x-intercept, is when your numerator equals 0. So when does x plus 1 equal 0? Now let's plot it. Asymptote, asymptote, asymptote there. And let's see. For the y-intercept, well, to get the rest of my graph, I'm going to pick a number to the left of the asymptote, a number to the right, and then for this asymptote, a number to the left and a number to the right. Substitute into your equation and see what we get. I'm trying to think of where I have enough space. Let's do it up here. So that's negative 5 plus 1, negative 5 plus 4, negative 5 minus 3, negative 4 divided by 8, which is negative 1/2. So right here. So that means this piece will be down here. When I substitute in negative 2, that is 1/10. So right above the asymptote. Now positive 2, that's going to give me 3 over 6 times negative 1, so that is -1/2. So this piece must be like that. And then then plugging in 4, we get 5, 8, and 1, which is positive, so that is up here. That's a tricky graph. Okay, as x approaches -infinity, y approaches 0. As x approaches infinity, y approaches 0. -4 is right here. From the right, it's going up to infinity, and 3 from the left is going down to -infinity. All right, write as a single rational expression. You must factor any denominator before you figure out your least common denominator. So since this term has 2 binomials and this one only has 1, I'm going to make my common denominator x plus 2 times x minus 2, which means this term needs to be multiplied by that common denominator in the numerator and denominator. So that gives me 2x minus 4 plus x minus 3 for a simplified numerator of 3x minus 1. For b, both denominators are different. So this first term needs the x minus 3. And the 2 needs the 4. So what I did is I took this first term times x minus 3 in numerator and denominator, and this one times 4. Distribute the x. And nothing multiplies to 8 that adds to -3, so this is our final answer. Nothing can be factored, but I would rather look at this problem as plus a negative. I think that makes it a lot easier to do. So my common denominator is x times x plus 1. So the 3 needs the x plus 1. The 2 needs the x. So that becomes 3x plus 3 minus 2x, which is x plus 3 divided by x times x plus 1. All right, factoring. X squared minus 4 is a difference of squares, so that can factor to conjugates. What multiplies to 6 that adds to -5 is -2 and -3. So my least common denominator is going to be x minus 2 times x plus 2 times x minus 3. So this one's missing the x plus 2. Distribute. So I combine my like terms, that's 7x, that's -11, write your denominator. Oh, we've got more, okay. 2x and x squared, a least common denominator for that is gonna be 2x squared. So this term is missing a 2, and this term is just missing the x. So that gives me x squared plus 4x minus, so I'm gonna think of this as plus a negative, so minus 2x plus 2 when I distribute that. So my numerator is x squared plus 2x plus 2 over 2x squared. In F, we have a complex fraction, so before I can proceed, I want to make one fraction in the numerator and one fraction in the denominator. So in my numerator, x plus 1 times x plus 2 is the common denominator. This term is missing the x plus 2. This one's missing the x plus 1. So that gives me 6x plus 12 minus 4x minus 4, all divided by the common denominator of the denominator. So this term was missing the x plus 1. This one's missing the x plus 2. So that gives me 5x plus 5 minus 3x minus 6. And now when you have a complex fraction, to simplify from here, besides combining like terms to make those numerators nicer, we're going to multiply by the reciprocal of the denominator. So simplifying here, this is going to give me 2x plus 8, and then x plus 1, x plus 2. So when I reciprocal the denominator, the x plus 2 times x plus 1 becomes the numerator, and then my denominator is 2x minus 1. And then to keep simplifying, any factor divided by itself is 1. So x plus 2 divided by x plus 2, oh, you can't see that pink. Another color. X plus 2 divided by x plus 2 is 1. X plus 1 divided by x plus 1 is 1. So we're left with 2x plus 8, 2x minus 1. And this fraction is our final answer. So let's multiply here, x minus 1. X to the third, if you like, you can think as x times x times x. What multiplies to negative 2 that adds to 1, give me negative 1 and positive 2. So what eliminates? X minus 1 divided by x minus 1. 2 of these x's with 2 of these x's divide. So our final answer is x divided by x plus 2. Now this problem with the division is the same thing as multiplied by the reciprocal. And the only thing we can eliminate is this x with one of these. So we are left with 2 times x minus 1 over x times x plus 4. Solve. Okay, so with solving, my strategy is going to be, if I can make a common denominator on the entire problem, I can then equate my numerators and leave the denominator for checking for extraneous solutions. Okay, so I see p times p plus 6 here. So I think this first term is just missing the p for my common denominator. So now I got 5p plus negative 1 equals 2. Okay, I think I made it more complicated by doing the plus negative in this case. So we're just going to change plus negative back to subtraction. Now to solve. So p is 3/5, but I have to check to see if it's extraneous. What that means is, will this solution make any denominator 0? No, this one won't, so that is my answer. All right, let's factor. You can usually use the other denominators to help you factor one that needs to be, because you know it'll most likely be included. So the x minus 2 is missing the x minus 4 for the common denominator. The 3x is missing the x minus 2. So that gives me x squared minus 4x plus 3x squared minus 6x equals 32 minus 2x. Then I can just equate my numerators. Let's combine like terms here. So this is 4x squared minus 10x. I'm going to move these terms to the left because I think I'm going to have to factor. All right, so let's factor that to solve. 4, 8, and 32 all have a common factor of 4. So what multiplies to -8 that adds to -2? Setting each factor equal to 0, well, that makes no sense. And let's see, if I take 4 and substitute it into this denominator, we get 0, so that is not a solution. If I take -2 and substitute, I don't get 0, so x equals -2 is the only answer to B. Bounded below. So that is saying the range has a minimum value to it. So -3x looks like this, so that's no. ln of x is this way, so that's not bounded below. Absolute value reflected, well, that's bounded above. And then 1 plus x squared looks like this, so that is the only option that is bounded below. 1-to-1 means that the graph would pass the vertical and horizontal line test. This is not 1-to-1. This one is. This one is. This one is not. Fill in the blanks. Okay, suppose that f of x, all right, this is the what, well, let me draw a picture. At 4, from the right, we approach a y value of 6. This way. The y value at 4 is 2. That's closed, this is open. It has a hole, or a removable discontinuity at 4. There's my graph that has a hole. As x approaches 4 from the left, we will still approach the y value of 6, since to be a hole, the pieces line up. All right, let's try that again. The y value is 6 as we approach 4 from the right. F of 4 is 2. It's a jump. So here's my jump. So as we approach 4 from the left, the y value is going to be 2, which is the bottom piece. Solve for A so that the graph is continuous. So I'm going to equate my pieces at 3. So any x gets replaced with 3. Subtract 12, we get 1 equals -a, -1 is A. A car manufacturer advertises that its new car model goes from 0 to 60 in 4 seconds. During the first 4 seconds, was the car speed ever exactly 20 miles per hour? Why or why not? Okay, so car speed is continuous. And since 20 is between 0 and 60, the car will have gone 20 miles per hour. If f of g is this equation, without using y equals x, which is the identity function, write the possible rules. All right, so what function g is inside? So it looks like x plus 7 is inside 54 plus 3x minus 11. Okay, we got to make this graph. X squared minus 3, starting at 0 and going lower. So that's 1 minus 3, 4 minus 3. But it's a closed circle because of the or equals. Oh, that's silly. That's negative 3. Sorry. 0 squared minus 3 is not 0. Okay, that makes more sense. And it's a parabola because of the x squared, so we know the function goes this way. We are at a y value of 2 from 0 to 2, so it's like a little barbell in here. Starting at 2 and going larger. All right, so that's the square root of 3, the square root of 4, square root of 5, square root of 6. So 2 square root of 3, well, let's see. 3 is a y value of 2. So the square root of 3, what number times itself twice is 3? It has to be less than 2 because the square root of 4 is 2. So it's going to be, I don't know, down here. Oh, but open circle. And slowly increasing for that square root function. All right, as x approaches negative infinity, the y value is going up to infinity. As x approaches infinity, the y value is slowly going up to infinity, eventually going to go up. As we approach 0 from the left, our y value is negative 3. 0 from the right, the y value up here is 2. 2 from both sides. Well, these are different values, so this does not exist because it has to be the same from both sides to get an answer here. 2x to the 2/3. All right, well, let's see. Let's first figure out if it's even or odd. Well, it's not going to be c because there's an asymptote and there's no undefined, like this, there's no can't divide by 0 here, so it's not c. I'm going to think of this as the cube root squared. So I can have negative values, so it's not d. And when I square a negative, it's going to get me a positive y, so the answer is A. Okay, so for 19, I took the negative exponent, moved it to the denominator. I prefer to see a radical. If you like the exponents, that's fine. So I cannot fourth root negatives. So this is not an answer, this is not an answer. So now we have to figure out one of these. If I substitute in, I don't know, positive 1 over here, that's going to be a positive result. Well, this is, so that must be this one. Which function grows fastest as x goes to infinity? The only thing I'm going to look for here are the exponents. Which exponents are is the largest? Okay, so 7 over 3 is a little more than 2. 5 over 4, that's a little more than 1. So it's C. That's the biggest exponent, because these are all less than 1. Ooh, the last page, that's exciting. Okay, based on the shape of this graph, looks to me like it's gonna have a 1/3 exponent. Like it looks like a cube root to me, which is the exponent of 1/3. write the rule. So I'm actually going to write the equation. So x something to the 1/3. To go from 0, 0 to 3, -2 goes right 3 and down 2. Y varies inversely with the square root of x, means that will equal a constant. Y is 2, x is 49. So that is 14 for k. So this is a good equation, it's just not a power function yet. So I have to isolate the y by dividing the square root of x to the right-hand side. Then I have to change that to an exponent. Then I need to make it so it's not in the denominator. So my final answer is going to be 14x to the -1/2. Last problem. Y varies inversely with the cube root of x. So the cube root of 8 is 2. So k is 6. Now we're going to isolate the y. Change my radical to an exponent. And move the term out of the denominator.